All right, we're back. We are still on page 7. And what we're doing is we're thinking about coterminal angles. Like, are the angles coterminal, meaning do they differ by some integer multiple of one revolution, right? So one revolution in radians is 2 pi, in degrees is 360. We don't have other angle measures yet, but eventually we might. So we are looking in general to find the principal coterminal angle. That's what I was doing in the previous problem. So in the previous problem, 10 is the principal coterminal angle for 1090 because 10 is the angle that's coterminal to 1090 between 0 and 360. In the second one, pi over 7 was the principal coterminal angle for both of those angles because it is the angle between 0 and 2 pi that is coterminal to both of them. So this is, you spend like an inordinate amount of time thinking about principal coterminal angles because they're in that first revolution, right? So anything that's true for those will be true for anything coterminal to it. So it's like it simplifies your work. So let's see if we can do this. Given the angle 48 degrees, find the coterminal angle reached by rotating the indicated number of times in the given direction. In this case, 48 degrees is the principal coterminal angle, which we know because 48 degrees is between 0 and 360, and that is what's required of that angle. So 5 times counterclockwise. So you just have to know, is counterclockwise positive or is it negative? So I'm going to say 48 degrees plus, because counterclockwise is positive, 5 times 360. Should we do this in our heads? 1500, another 800 is 1800. Why is that? Oh, because it's 10 times 180. That's like 1800. Yeah. So this will be equals 18 and then another 48. We'll check it on the calculator, but I'm pretty confident on that one. All right, 10 times clockwise. Clockwise is a negative rotation, which means we're going to do 48 degrees and then minus 10 times 180. So that's 10, 8, no it isn't. It's 1800. And if I subtract 45, so that's going to be 1755. It's usually easier to just guess those than it is to actually like do the work on them. You know, it's up to you. But then I want the negative of that because I did like the negative of the problem. So this will be negative 1755. We will check it on the calculator. 43 times clockwise. I'm not even going to try to do that one by hand. We're just going to do it on the calculator. 48 plus 43. Clockwise. Clockwise? What? Wait, am I screwing up counterclockwise and clockwise here? Also, why does that freeze sometimes? I don't need anyone to have an answer to that. I am. What? Counterclockwise is positive, is net pop. Whoo. Counterclockwise is positive. So this should actually have been plus, which means that this answer is just flat out wrong, which is great because all that work was for nothing. So that's good. So this will just be 1848. 1848. Okay. So wait a second. What is happening here? Oh my God. What am I even doing? Why am I doing 180? This is me crumbling. You're seeing it. 10 times 360. All right, I've gotten this wrong every way possible, so that's good. Let's get that out of the system, you know? So this will be 3600, but then another 48. 3648. We'll check that on the calculator for sure. We're in strong check on the calculator mode. That's what happens to me. So I'm actually dyslexic, and sometimes my brain just switches things left and right, up and down, horizontal and vertical. These are all things that I will switch. And when I switch, it's really hard to notice, which is part of why I advocate practicing as much as you can, because you know, something about what we were doing suddenly made my brain say, like, maybe not, maybe don't do that. And thankfully, it was in time. In time for what? I don't know. In time for me to not post this on the internet with all the mistakes, I guess. Not doing that by hand. All right, 3 times clockwise. Clockwise is negative. So we want to do 48. Then we're going to subtract 3 times 360. So another way of thinking, I keep writing minus 3 times 360. Another like perfectly valid way of thinking about it is plus 3 times negative 360. Right, we're adding 3 negative rotations. And however you want to think about that. So that's like negative 1080. So if I do 1080 and subtract 48, that'll be 1032. So this should be negative 10. 32. Okay, so let's keep going, then we'll check those on the calculator at the end and just see how it went. Describe a general method of finding all angles coterminal to 48 degrees. Okay, this is going to be a big deal. So you're about to meet one of your new best friends, and let's see what it is. So let X be the angle coterminal to 48 degrees. So X is going to be, you start at 48, and then you just want to add like a multiple, an integer multiple of 360 degrees. So I'm going to say plus n times 360 degrees, but n has to be an element of the integers. N is an element of the integers. That's it. You're going to write that so many times. And you're going to forget it so many times, and it's going to drive me insane. So you could write 360n, totally fine. But you have to do the n as an element of the integers. If you don't do that, you're not right, because n can't be just any number. It can't be an element of the reals. It has to be an integer. Could be a negative number, right? You can have negative integers, negative 10, negative 58, all negative integers. Find the minimum value of x such that x is coterminal to 48 degrees and x is greater than 25,000. Well, this is actually not that bad because we already know what x is. X is this. So I'm just going to say that I need 48 plus 360n to be greater than 25,000, but also I need n to be an element of the integers. Okay, so now that I'm definitely just going to use a calculator to solve. So let's switch over to the calculator. I'm going to check the answers and also find the ones that we didn't find. So switching to the calculator. So get out your calculator, get ready to press some buttons, see if you can keep up. So I wanted to do just 48 plus 5 times 360. Uh-oh. Frozen. Oh, and it's back. That was weird. Is it still working though? That's the real question. Who knows? This thing freezes up now a lot. You know what I'm gonna do? I'm gonna define x as a function of n. So to define a function, it's x is a function of n, x of n. Then I'm gonna do this. So colon equals, which is control and the templates button. And I will say it's 48 plus 360 times n. We don't really need that multiplication symbol. It'll put it in for you. Like if you do 45n, just 45 times n. So now what I can do is I can press the var key and I'll do x of 5, right? So n is 5, so I should get the same answer, and I do. If I do x of 10, so it's start at 48 and do 10 times 360, I get 3648. If I do, so now I need to know that, man, I'm screwing that up. I need to know that clockwise is a negative rotation, so I'm going to do minus 43 times 360. I get negative 15,432. So let me write that in. Negative 15,432 degrees. That's very negative. And then 3 times clockwise, so x of negative 3. I get negative 1032. So that's what I got. All right. And then finally, I want to try to solve this equation. So I'm going to do menu 3, enter for solve. And then I'm doing x of n because I already entered that, right? That's my formula for coterminal angles, angles that are coterminal specifically to 48. I need that to be greater than 25,000. And I want to solve for n. Not useful. So let's do control enter. So you press control, you press enter. I get 69.311. So I'm gonna write that by hand. So n is greater than 69.311, and n is an element of the integers. So if that's the case, I'm gonna try to go back to the notes. This often doesn't work after it freezes, and it's so frustrating. Hopefully this is gonna work, we'll see. If it doesn't work, you'll never know because I'm gonna have to re-record the whole video. So that's sweet. Maybe I won't mess up clockwise and counterclockwise. A silver lining, right? So I'm back here. So think about this. N is greater than 69.311, and n is an element of the integers. And furthermore, we are looking for the minimum value of x. So I think that n is actually going to be equal to 70 because that's the smallest number that satisfies that. But that is not the answer. The answer is we need to do, therefore, x is going to be 48 plus 70 times 360, which I'm just going to do it on the calculator. I'm not going to make you watch. I just need to do x of 70 on here. And I get 25248. So this is equal to 25248, which is almost, it's definitely the smallest one that is bigger than 25,000 because 248, well, actually, I guess my reasoning that I was about to give isn't necessarily right. I was going to say because 248 is less than 360, so you're like less than 360 more than 25,000. Is that logic right? I don't really know. I think there's something wishy-washy about that logic that I'm trying to use there, but I'm confident that it's right. So what I'm going to do here is I'm going to stop the video. I'm going to really hope that this video actually recorded, and if it did, I will see you in the next one, and if not, although you won't know it, I'll see you in this one again. So one way or the other, see ya.